Everyone, welcome to this video on lesson 6 of the Earth and Climate scheme of work. This lesson is on sedimentary rocks, and with all these lessons in this mini sequence, it's worth starting by just going back to the rock cycle and kind of relaying the whole story to students, and then showing which part we're going to zoom in on in today's lesson. So in lesson 4 we looked at the igneous rocks and how magma rises, cools and solidifies to form those rocks like basalt, granite, obsidian and so on. Last lesson we looked at weathering and how rocks get broken down and moved by various processes, so that by the time they get down towards the sea, they're quite often quite small, and that's what they end up like when they're in the sea. What we're going to look at today is this part of the process. How is it that these sorts of rocks are formed, sedimentary rocks, and how does that relate to what's been before and what's going to come afterwards? So the first thing in these lessons on rocks, the 3 lessons on rocks on igneous, sedimentary, metamorphic, is make sure you get the rock samples out. So the first thing students can do is just have a look at some sedimentary rocks. And there's lots you can draw their attention to, so I might start with some, which one's this? I believe this is the sandstone. So we've got some sandstone here, and you can draw their attention to that, and they can see that it kind of looks like sand, which is good. And if you, again, you can do this under the visualizer, but you should also model to them how they should do this. But if they zoom in quite closely, hopefully they'll see here, actually that's just lots and lots of tiny grains of sand squashed together. So they can start to see what's going on here. We've got another example of sandstone here. This is desert sandstone, so not, well, it probably was the sea at some point, but it's not near the sea right now. What's interesting here is, and it's kind of hard to see under the camera, but firstly you can see there's all these grains, and students might ask, they've certainly asked me before, what's the difference between grains and crystals? Because I don't know whether you can see on here. Yeah, but maybe you can see there are a few shiny bits in this desert sandstone, and I suppose it's a tricky one. But if we relate it back to the rock cycle and say, well, look, the sand that we get on the beach, a lot of it it's just igneous rocks that have been weathered and brought down towards the sea by transportation. So you could say, well, these shiny grains, I mean, they're kind of bits of broken crystal, rather than these kind of nice, neat crystals that we get in the igneous rocks. So that's something you can draw their attention to. We've got some nice limestone here. So this is a bit different. You can point out to them that the limestone is actually not formed by sand falling, but it's formed by the sedimentation of kind of remains of plants and things like that. So they can have a look, and yeah, they should get up close and personal with these rocks and yeah, look at that structure themselves. Limestone is famous for, there's lots of fossils in limestone, because yeah, if there's plants gathering at the bottom of the ocean, well, there's probably going to be bits of animals and stuff as well, and you can get fossilized fossils of plants too. We can also show them some chalk, so they'll be probably quite familiar with chalk, but again, this is full of calcium. It's full of kind of bits of this is the remains of plants and animals that have fallen to the bottom of the ocean, and you get lots of this in the southeast of England in particular, and down in Dorset. And you can start to see, I mean, it's not perfect here, but you can start to see some of the kind of layers here, and you may have samples which show that more clearly. I think the one I had was this desert sandstone. You can kind of just about see, apart from the way that it's cut, but you can kind of see some layers here, and you might get examples which show that even more clearly. One thing to draw students' attention to is that layers doesn't necessarily mean sedimentary, because you've got lots of metamorphic rocks with layers as well. So yeah, just be careful with that. But if there's layers, that it could be sedimentary, but sometimes that's clearer at the rock formation level rather than the individual rock level. And then this conglomerate. So again, this you can really see how this is the product of bits of rock being broken, falling to the bottom of the ocean, and then somehow being glued together, which we'll talk about in a minute. But you can see all of these little bits of pebbles and stuff, all kind of somehow stuck together it's a bit of a mess, but this is conglomerate, and again, this is it's really common to find fossils in conglomerate as well. So what we can do is explain how it is that this happens, and give students a picture that explains why sedimentary rocks have some of those features, and relate that to the broader rock cycle. So I would just keep this really, really simple. So if we've got our kind of seashore, and I'll draw some grains of sand on here like this, and then I'm going to draw the sea in blue, just like that. Try and get it level. What we can say is that in the ocean, over many millions of years, these grains end up getting washed into the sea, and they sink, as do the remains of kind of living things. So we could do a few fish bones here like this, and we could draw bits of plants as well, and all of this stuff ends up gathering at the bottom of the sea, and you start to form these layers. So we can say, yeah, you can draw these layers in like this, and this is the first stage, this just building up of lots and lots of stuff at the bottom of the ocean, and we call this first stage sedimentation. So you can draw attention to the fact that the building up of layers is called sedimentation. And that's a word that we want them to be able to use. What happens next is that as more and more layers build up on top of one another, these upper layers, the weight of those starts to press down. We start to get some pressure from above to down below. So the bottom layers get squeezed. And what I'm going to do is show this happening by kind of showing the layers getting even more packed in, more tightly together, down towards the bottom. So these bottom layers are getting squeezed like that in a process that's called compaction. So they're being compacted, which just means they're being pressed together. So this is compaction. So that, and again, this is something that doesn't happen overnight. This happens over many millions of years. But over time, what happens is these get squeezed and squeezed and squeezed until all of the water is squeezed out. So if I draw my sea up here, and I can draw my layers on here like this, and again they're less tightly packed towards the top, and then they get much more squeezed down towards the bottom. That, and what happens is the water starts to get forced out. So I could zoom in on here and show this last stage like this. Which is that the water gets forced out. So these are the grains of sand, or it might be squashed bits of matter that was previously living, so plants and animals and so on. So the water gets squashed out, so all the water gets pushed out because the pressure is so high. And then what happens is salt from the water and other minerals kind of glues these grains together. So we get this kind of these grains get locked together like that, and that process is called cementation. So I'll draw a line from the kind of glue that I drew there. This process is called cementation. Effectively, it just gets cemented in. And that's how, and we can see the cementation really clearly in the conglomerate, and it's worth coming back to your rock samples. But what's happened is the water's been squeezed out, and essentially those little bits, those grains, have been stuck together by the salt from the seawater and other minerals like that. And then what you can say is, well, and actually, because of this process, what you can get in here is sometimes a little bit of a fossil. So I might draw an ammonite here like this. A little bit of a fossil can get stuck in there as well. You might even, if you want, you could talk about dinosaur bones. My brother is a great fossil hunter, so yeah, you can add some sort of a bone in here as well like this. So when people are looking for fossils on the beach, well, usually what they're looking for is they're looking in amongst sedimentary rocks. And lots of the coastline in Britain, around Dorset, famously Mary Anning went and found lots of dinosaur bones around Lyme Regis. Lots of the coast in Britain is made up of sedimentary rock, like chalk and limestone and things like that. Yeah, that's why there's lots of fossils there, because they get preserved in and around those grains that are cemented together. So we can make a note that these are fossils, and they'll know what fossils are. Or they should do. I mean, that's taught in primary school, and generally, in my experience, students have been pretty happy with the idea that fossils are the remains of living things, and we can emphasise to them that the main place you're going to find fossils are in these sedimentary rocks, because of how those sedimentary rocks are formed. And that's really it. In the questions, it's just describing this process, so turning this into words, and also explaining why you don't tend to see crystals in the same way in sedimentary rocks, because it's formed by the building up of layers rather than magma cooling, and it's during that cooling process that the crystals grow. And also why you get fossils in sedimentary rocks but not in igneous rocks. Final thing to say is I put some examples here of kind of rocks and rock formations that students can have a look at, and they should be able to identify whether things are igneous or sedimentary. We want to get to the point now where they're starting to look for these key features. So does it have fossils? Does it have layers? Does it have crystals? And so on, and identify from there. And of course, there'll be more of that sort of thing in the next lesson, which is on metamorphic rocks.